Ordinary general annuities. As a review, in the previous chapter, we talked about ordinary simple annuity, and that was the situation where we have conversion period equals to payment interval. And what that means was that the compounding per year equals to the payment per year. So that's the definition for simple annuity. And we also assume that the payment were at the end of each period. And when payments are at the end of each period, we call it ordinary annuity. And in today's chapter, we're going to learn about ordinary general annuity, where we have the situation where we're still having the payment at the end of each period. So that's the definition for ordinary annuity. We're still having the payment at the end of each period. The only difference in this chapter is that now our conversion period does not equal to the payment interval. So our CY, our compounding per year, does not equal to our payment per year. When CY does not equal to PY, we call it general annuity. And this is what we're going to cover today. We're going to cover ordinary general annuity. So payment at the end of each period, and then the conversion period does not equal to the payment interval. This is what we're going to cover today. Next class, we're going to cover the situation where we have the payment at the beginning of the period, and what we call that is annuity due. An example of ordinary general annuity is the mortgages in Canada. In Canada, most of the home mortgages are compounded semi-annually, so CY is 2, but the payments are often made in monthly, semi-monthly, or bi-weekly. So therefore, our compounding per year, our CY, does not equal to our payment per year, our PY. And that's the definition for ordinary general annuity. And algebraically, the difference between ordinary simple annuity and ordinary general annuity is that for ordinary simple annuity, we use the periodic interest rate I, while for ordinary general annuity, we use the equivalent rate of interest per payment period, which is P, and that's the formula for P. So that's the difference algebraically. Example 1, a property worth $96,500 is purchased for 5% down and quarterly payment of $2,000 for 18 years. What is the effective annual rate of interest if interest is compounded monthly? So in this question, what we're looking for is the EFF. And in order for us to find the EFF, what that means is that we need to first find the nominal interest rate, the IY. So that's why we have the question mark for the IY. And to find out the present value of the mortgage, what we're going to use is the formula here. We have purchase price equals to down payment plus the present value. Purchase price is $96,500. That's what we have here, $96,500. And then we made a 5% down payment. So down payment, so $96,500 times the 5% plus the present value. So present value is the mortgage. And when we do the calculation, we take 96,500 minus the 4825. We're going to get present value equals to 91,675. So that's the present value. That's the present value of the mortgage. That's how much money we're borrowing today. And that's our mortgage, and the mortgage is our present value. That's how much we owe today. So that's why we put the 91,675 as the present value, and that's our mortgage. So present value is basically purchase price minus the down payment. The next number that we see is $2,000. $2,000 is our PMT. The reason this is our PMT is because this is repeated at a regular time interval, and the amount is constant at $2,000. And the reason the PMT is negative, with negative $2,000, is because we're paying down our mortgage. So every period, we're making a $2,000 payment, and that will reduce the balance of the mortgage. So at the end of 18 years, our future value is 0 because we completely pay off our debt. So at the end of 18 years, we don't owe any more money, so that's why our future value is 0 at the end of 18 years. And then our PY is quarterly payment. So quarterly payment, that means our PY, our payment per year, is 4 times a year. So that's why we have PY equals to 4. And we have the interest compounded monthly, so our CY is 12. So our compounding per year is 12 times a year. And the last number that we need to solve for is N. So we know that when there is a PMT, then our N equals to T times PY. So T is 18 years, and then PY is 4. So 18 times 4 give us the 72. That is our N. So once we have all these numbers filled out, then we can put it into the financial calculator. So we start from the PY and CY. So second function, PY is 4, enter, and then we go down. Our CY is 12, so we type in 12, and then we press enter. Once we have typed in the PY and CY, we clear the bottom left corner, and then we start typing in the N, so 72, and then we press N. That will set our number of period to 72, and then we have present value 91,675, so 91 91,675, and then we press PV. That will set the present value to 91,675, and then we have the PMT negative 2,000, so 2,000 and then negative, so plus minus is the negative sign, and then we press PMT, and then we press 0 for future value. Once we have typed everything, then we press compute, and then we compute for IY, and then we're going to get 5.384, and that's the nominal interest rate that we have. That's our NOM or IY, nominal interest rate. So once we have the nominal interest rate here, then what we're going to do to find out the effective rate, how we're going to find the effective rate is we're going to use second conversion, so second function I conversion, and then we follow these steps here just like before. So what we're going to do is we're going to press second function I conversion. I conversion is right above the 2. We're going to type in the 5.384313. So 5.384313, and then we press enter. That will set the nominal interest rate to 5.384313, and then we go down 2 times to CY. So we go down 2 times to CY. CY is 12, so we press 12, enter, and then we go back up to EFF. So we go up 1 time to EFF, and then we press compute, and then we're going to get the 5.52%, and that's your answer for example 1. So there are 2 new things that you need to know from this question. The first thing was you need to know where to get the CY and the PY, right? So we have the quarterly payments, so that's where we get the PY. So the PY always come from the payment per year, and then the compounding per year, that's your CY. That always comes from near the interest. So the first concept is you need to know where to get the PY, where to get the CY. The second thing new about this question is that you need to know that purchase price equals to down payment plus present value. And present value is what we put into the boxes. So those are the 2 new things that you need to know from this question.